Hi, students. Let's do section 11.6, which is some more stuff on graphing these quadratics. So we're going to learn today how to graph a quadratic if it's given to us written in standard form instead of the general form that we saw in 11.5. And we're going to learn how to find the intercepts of our quadratic, okay? So those are the x-intercepts where our graph crosses the x-axis, okay? So for example, let's say we have this quadratic function, f of x is equal to x squared minus 2x minus 3. So we know that that's a quadratic function, but it's not written in our standard form or in our general form. It's written in what we call standard form. And so we can't exactly see from those values where our vertex is going to be, or what it would look like if we wrote it in standard form. So the trick is we are going to rewrite this in our, general form so that we can see the vertex. And then after we have identified the vertex, we're actually going to set it equal to 0 and solve this equation so that we can identify the x-intercepts as well. Okay. So how do we get this guy that's in standard form into our general form? And to do that, we're going to use the process called completing the square, which we actually did when we were solving some quadratic equations previously. So hopefully you still remember that. So for completing the square, what we are going to do is we are going to engineer a constant term that relates to the coefficient on our x term in such a way that this will factor into a perfect square, but there'll be some extra constant term that we're going to ignore. Okay. So remember when we completed the square before, when you have a perfect square binomial, the constant term needs to be the coefficient on our x divided by 2 squared. So we take the coefficient on our x, we divide it by 2, and we square it, we're going to get 1. So in order for this to be a perfect square, to complete the square, our constant term actually needs to be a 1. So we can do that by just adding a 0, right? We're going to add 1 and subtract 1, so we're really just adding 0 here. And remember, we picked this 1 because it relates to this coefficient perfectly, so that these 3 terms now will factor into a perfect square. So we can combine our last 2 terms, the -1 and the -3. Those are just kind of extras that don't help us factor to a perfect square, so we'll combine them. And then these remaining 3 pieces, the x squared minus 2x plus 1, factors to x minus 1 squared. All right. That factors to x minus 1 squared, and then we've got our -4 here. And you see by doing that, completing the square process, we got ourselves into general form. And now we can see clearly that our vertex is at 1, -4. Perfect. So that's how completing the square helps you turn a standard form quadratic into a general form quadratic and allows you to identify clearly what the vertex is. Okay. Now, because I use graphing software, I can pretty much see that we're going to cross the x-axis at x is -1 and x is 3, meaning that y equals 0 when x is -1 and when x is 3. We can see that, but if you had to graph this by hand, right now we only know that our vertex is here and that we kind of open up in this direction. So what we're going to do is then identify where these intercepts are algebraically. Right. So we still want to confirm where these intercepts are. So remember, our equation here is in our equation right here is in the general form, and our equation here is in what we call standard form. Both of these equations are equivalent because all we did to get from one to the other is we added 0 and we factored, right? And that shouldn't change anything. It just changes the format. In this form, we can see what the vertex is. In this form, we can't see the vertex, but this form's easy to solve for 0. All right. So we're going to take our original general form and we're going to find the intercepts just by setting y to 0. We're going to say that our output is 0, right? That's when y is 0. And we're going to solve that equation to figure out what values of x make that true. Now, keep in mind, we could use our standard form equation. If we set it equal to 0, we'd add 4 to both sides, take the square root, and then add 1 to both sides, right? So we could do that. Now that we're in this completed square form, we can use the square root property to solve that. But we can also use just factoring to solve it from the standard form. So we're just going to factor this guy, and then we can see that when y is 0, x is either 3 or x is either -1. So we have these points, 3, 0, and -1, 0, that are the x-intercepts of this graph. Okay. So that's how you find the x-intercepts. So just to recap, when you are given something in standard form, you want to graph it. To graph it, you have to complete the square to get it in our general form where we can see our vertex. All right, so once we identify our vertex, and we can use the fact that A is 1 to get a general idea of how it opens up, but it's also helpful when graphing to know what the intercepts are. To find the intercepts, you just say that the output is 0 when y is 0 and solve for the x values. Once you have all those points, the vertex and those intercepts, it's very clear what shape your graph is taking on. Let me give you one little shortcut information if you want to find the vertex without completing the square. You can actually do that. There's a formula based on the coefficients of our standard form. There is a formula that will tell you what h is, basically, okay? And it comes from just completing the square on the standard form. If you want to follow along, you can. I'm just going to show you how I'm going to get this formula. So if we have coefficients a, b, and c, and I want to complete the square here, then I know my constant term needs to be this term here divided by 2 and then squared. But if you have a coefficient outside of the x squared, remember when completing the square, you first have to have a 1 for the coefficient out here. So if a is something other than 1, we have to divide every term by a. So first you divide every term by a, right? And then our constant term needs to be the coefficient here divided by 2 squared. So our coefficient here is b over a. So we need to take b over a, divide it by 2, and square it. That's what our constant term needs to be. All right, so b over a, we divide by 2, puts a 2 in the denominator, and squared. This piece right here, this b over 2a squared, is the perfect constant term that we need to complement this b over a coefficient to make these first 3 terms fold into our perfect square. But notice if we added this b over 2a squared, we also have to subtract b over 2a squared, and we still have this c over a, which was whatever our original constant term was divided by that first coefficient, okay? So these 3 pieces, so these 2 pieces here, the plus and the minus, that's our addition of 0, right? So we're not really changing anything, we're just adding 0. But this first of that piece that we're adding is the coefficient we need to make these first 3 terms fold into a perfect square. And then that remaining stuff is just going to get added together on the outside. Okay. So we fold those first 3 pieces into that perfect square because we've designed them to be factored into a perfect square. And then this stuff on the outside is all just a bunch of constant terms that can get added together once you have a concrete equation with actual numerical values for a, b, and c. Okay. But notice here that this is our general form of a quadratic. So this is our minus h. All right. And then this stuff is all our K. All right. So that means that our vertex, the X coordinate of our vertex is going to be negative B over 2A. So the X value of your vertex, if you are in a standard form, will always be negative B over 2A. Okay. That's because that's what would happen if you completed the square on that, right? Now notice I didn't tell you what our Y term is, and actually your Y term is all this stuff over here. Negative B over 2A squared plus C over A, that is your Y term. It's really easier though to just plug in whatever you get for your X term. You know, your X value at the vertex is negative B over 2A. It's easier to just plug in that value into your standard form equation and figure out what Y is than it is probably to calculate B over 2A squared made negative plus C over A. Okay, so this is your vertex if you have a standard form and you don't want to complete the square. But a lot of times you're going to be asked to write your function in general form. So it's good to practice completing the square there so you can see it in general form, and then you know your vertex is HK. All right. Good luck with that. Definitely review completing the square if you can't remember that well, and also understand this this formula down here. I know it's a little confusing, but basically B and A are just going to be coefficients. You do negative B over 2A, that's your X value. And then F of, so your function evaluated at that X value is going to be the Y value that corresponds with that for your vertex. All right, students, good luck.